Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah wassalatu wassalamu ala Rasulillah. Amma ba'du. Alhamdulillah, all praise to the God. We can meet again in this great day, in Friday. So we can continue our lesson in competitive programming. And before we start our lesson, let's begin with praying together. Allahumma inna nas'aluka ilman nafi'an wa rizqan thayyiban wa amalan mutaqabbala. Allahumma inna na'udzubika min ilmin la yanfa' wa min qalbin la yakhsha' wa min nafsin la tashba' wa min da'watin la yustajabu laha. Rabbana zidna ilma warzuqna fahma. Ya muqallibal qulub tsabbit qulubana ala dinik. Amin. Alright, as usual, before we discuss competitive programming, we will read two ayah. If in the previous meeting we already discussed that Allah sells paradise, so paradise is the commodity of Allah, and then we will discuss about trading with Allah will never lose. We will always get profit when we trade with. So let's read this ayah from Surah Fatir, verse 29. So maybe can Abdullah read this? Yes, please recite this for us. Yes.
Am I clear, sir?
Yes.
Bismillahirrahmanirrahim. إن الذين يتلون كتاب الله وأقاموا الصلاة وأنفقوا مما رزقناهم سرا وعلانية يرجون تجارة لن تبور.
Yes, thank you very much. Jazakallah khairan. Yes, this is Solah. Alright, so from this ayah we know when we recite Quran or we pray or donate, so it means either it is a good deeds from our lives or from our wealth, from our money, either secretly or openly. It means we are trading with Allah, right? And you know, this tijarat will never fail. All right. So anyone who trade with Allah will never fail. All right. That's it. All right. So let's see. Let's read one more ayah. Maybe can Hashim read this? Please recite this for us. Okay, your mic already opened, but your voice not heard yet. Okay, maybe.
Am I clear, sir?
Okay, for Abdullah, I heard your voice.
Wait, بسم الله الرحمن الرحيم أولئك الذين اشتروا الضلالة بالهدى فما ربحت تجارتهم وما كانوا مهتدين.
Yes, thank you very much. Okay, this is from Al-Baqarah, second surah after Al-Fatihah, right? In the verse of 16. All right. And sorry, this is not Dhammah, not treated with you, but no need to read them. All right. And from this, if we see the other side, there are some people that they are trading guidance for misguidance. So it is not good, right? They sell guidance, so they not get guidance anymore, and they pay for misguidance, so they are not rightly guided. And we know this tijarat, this trade is profitless. All right. So when we trade guidance for misguidance, it is profitless. But if we trade by doing good deeds, not bad deeds, this is never fail. Will always profit. All right. So this is different between mu'min that trade with Allah and and non-Muslim when they are not guided. All right, that's it. So I think 2 ayah is enough for today. So let's continue our discussion about some of our subset. And I think since it is new topics, I think I should show you the implementation, right? And okay, your senior already solved some problems before, I think, because this problems is from code force, so you can easily find it. All right. So we have discussed the idea in the previous meeting, right? So let me show you how to implement it. At first, we will make a adjacency matrix, right? So just make an adjacency matrix. So let me show you the implementation. First line of input is N and M. All right. What else? That we will input M lines. right? And we will store the adjacency matrix, right? You know, we will store them into mask. And to make it easier, I think we should change it into zero base, since it is not affecting the answer, right? So just reduce both of them and then just make like this. Adjacent x or with 2 to the power of y, vice versa. Is it understood why I write this formula? After that, we will check whether whether a subset is is correct or not. Maximum bit is 2 to the power of maximum n. All right. We will try to brute force this. Wait. Wait. All right. And we will store the index as well. Start from 0 index and 0 mask. And we will brute force index plus 1 mask or index plus 1 mask or 2 to the power of IT. All right. And the best case is when IT is equal to n. Then it means if the mask is equal to 1. Is it correct? New simple number connected to component. Okay. All right. And just return. And here, when we don't use a node, there is no condition we have to fulfill, right? But if we want to use a node, we have to make sure that this node can connect all of the current nodes. So just make sure that mask and adjacent of ID is equal to mask itself. You know, so for every mask, it is adjacent with this. In that case, we can use that. All right. Is it understood? So, do you know what is the complexity of brute force? Can you predict the complexity of this? Just think in the worst case. The worst case is when the graph is complete, right? So we always calling this function. So what is the complexity? This is a recursive function with calling to other function. So we multiply it with m. Is this multiplied with m? So from 0 we'll call to function, right? From index 0 we'll call to function with index 1, and the complexity is just O1, right? Each function only is complexity of O1, constant complexity. And then from this we'll call function 2. Sorry, function with index 2. And so on until function with index n. So what is the complexity? Yes, just 2 to the power of n. So 2 to the power of n is enough. So no need to use 2 to the power of n times n square or even times n only. We can make it 2 to the power of n times 1. Okay. Maybe some people solve this problem using this complexity or this, but in fact we can do faster, right? But this is just for checking whether that mask is complete graph or not. And then we so find the minimum possible number of connected component in the graph after removing such edge, right? We have to find minimum connected components. So it means we solve to dynamic programming, right? We solve to dynamic programming. And then the C out the output is KP minus 1. Okay. All right. For this case, for this problem, we don't use sum over subset, but we will try to use any subset added by the rest of the mask, right? So the only option is we need to iterate for all submask. How to iterate all submask? Wait, we need to change J into J minus 1 and I. Okay, we can put it here. J equal to J minus 1 and I. All right. And then If TPI is equal to 1, then just continue, right? It means it is complete graph, so just continue. But if not, then let's make it infinite or just make it n, and then try to do this. TPI equal to minimum between TPI and TPJ plus TPI XOR J. All right, this is the transition. Is it understood? So, do you know what is the complexity of this? The complexity of this is equal to 3 to the power of n, right? 3 to the power of n. Okay, 3 8. But don't worry, I think the operation is so the operation is fast. So it is so like, so we hope it is past the time limit. Or we can also start from, wait, can we start from I divided by 2? So no need to use this, right? Never use this. Just use this one. All right. It is also okay because it is symmetric, right? If we use A and I in, sorry, if we use J and A XOR J, if J is less than half, then this one is greater than half because the sum of them is equal to I, right? So we can start from I divided by 2. All right. Wait, so we use this as well. How to speed up this? Maybe don't do this, but just just minus with the most significant bit, right? But I think even we don't do that, it is still past the time limit. So let's check. Where is it? Here. Okay, so what else? One. All right, 5. And here is 18. Okay, yes, this is 18. So we can try to submit this. English from headquarters. All right. So let's next. For this case, maybe we need to edit this, right? We need to change from string to integer. Maybe we can use ChatGPT to print all of the all of this separating by comma. You can try to make a comment like that. Or we can also get that from the other solution. Okay, maybe let me try to use ChatGPT instead. Okay, wait. uh, or chemical element with with triple quote or between rated by commas. Let's try to wait. It just need the symbol, right? Just print the symbol with two. Wait, but there is no a triple quote. For its symbols. Okay, finally. Wait, but is it sorted by atom number? I think not yet. Hydrogens, hydrogens will be the first one. Sort them by atomic number. Wait. I think we cannot directly use this. Where is hydrogen? There is hydrogen here. So print our chemical element between double print or symbol of chemical elements sorted by atomic number. Okay, finally. I hope this is correct. So let's count the number of items here. This is the third one. This is the 1191. So how many commas here? 117. All right, so there are 118 elements. Yes, I think it's correct. Okay. The atomic number does not exceed. Okay. So I think 100 is enough, but don't worry. No problem if it is, if we create the array until 118. Yes, we can use this. Let's make an empty string for 0th index. So this is the string, and we can add a map of string and integer like this. String IT, for example, to change to convert them. All right, so given n and k, that n elements, make them zero base. And at first we will iterate for all atomic numbers, right? ID of element I is equal to I. So when we input like this, then just change into an array. Now maximum n is only in this 17. Okay. And then we will iterate from 1 until k. Now it is this one base. And then we want to do prefix sum here. That's why I name it as pi. All right. So we will create a dynamic programming function. So we will solve like this. Okay, at first we need to find the sum of its values. So maybe no need to make an array since we can use at once. So from here, the definition of TP is like this. TP mask means we can create or we can split the elements. We can split the elements into, sorry, we can split the element into into the item with size p, right? Or the maximum prefix we can create, or we can split. All right. So, it is just like we want to try for its permutation of this. So for any permutation of this, if we can split one of them become equal to this, and the next is equal to this, and the next is equal to this, then it means this way of splitting is correct, right? Okay. Because we want to make a permutation or make some values, so it came to the first of the permutation, right? And then this is after that, and this is the next. Okay, so just like want to try for all permutation, but if we brute force them with 17 permutation, 17 factorial, first it is so big. That's why we will create dynamic programming with bitmask. So the complexity is just 2 to the power of 17. So so here we will try to check for all previous elements. Wait, from 0 until n. If j bit is on, so just do this. dpi is maximum of dpi and dpi XOR 1 to the power of j. Sorry, 2 to the power of j. And then after that, we will find the sum. Or just to here sum plus by aj. All right, so sum means the total elements in this mask. If sum is equal to dpi plus 1, sorry, prefix of dpi plus 1, then dpi plus plus. All right. And finally, if dp minus 1 is not equal to n, it means it is impossible. So just print no. Otherwise, print y, print yes, yes, okay, and then print the backtrack. But before printing the backtrack, just check whether this dynamic programming is correct or not. Wait, this is no. I think we should check the index here. Wait. Okay, I think this is not n but k. So this is not n but k. All right, let's try again. Okay, yes. So we got the back. How about this? This is yes as well. And the response will be no. All right, so just find the backtrack and or find the configuration. Just use backtracking like this. Just iterate for initially the mask is equal to p minus 1. Okay. While mask is equal to mask is greater than 0, right? While mask is greater than 0, just do this. Maybe we solve create a string of answer, maybe. Yes. Okay. Wait. Yes, I think we can create string of answer. And then, or we can also make an array of answer as well. So just do this. Just find the sum here. And the complexity for this backtrack is only n square. So it is so small, so fast. Just try to find the sum. If the sum, or let's make it I, so no need to change this. If the sum is equal to the GPI, it means we start from that, right? So we already get a permutation that the sum of this is P1 and the sum of this is P2, and the sum of this is P3, and so on. So when the sum is equal to TP, so we are starting to add that, right? So we will do this. When sum equal to this, then we will let's make it like this. If sum equal to this, then k minus minus. It means we will start to add the previous elements, right? Okay. All right. And then what else? Maybe we can store this as array as well, since it is useful. Even we can use array E, but if we store this, it is easier. Okay, so after we got the sum, or let's show you how to output them after this. Let's iterate from 0 to n. Read to k, and then we will output answer I, and then a row ti plus 1. yti plus 1 because this is one piece. All right, yes, there is a row here. And then we will do backtrack, right? We want to find the previous value that the GP is equal to K. If the GP is equal to K, okay, then go there. Right. And don't forget to add to the answer. So we will add answer K by the string of J. If answer K is not empty, then we will add plus because they are separated by plus. Okay, let's try it. It is not declared. All right. Okay, this case is no. No need to output the configuration. But how about this? Okay, 8 plus 8 helium. Helium. How about this? Okay, is it same? Okay, no need to make them sorted, right? Wait. Okay, yes, maybe this is also correct. There are more than one solution. Okay, yes, right. So this is the solution. Is there any question about this? You can try to submit this as well. All right. So let's continue to the third one. For this one, given a rooted tree, as we have discussed it before. All right, so I think the idea already explained, or we have explained the problems, right? So let's just implement them. Or you may save this code first before I delete them. So the input is started with an MQ, and then we will iterate M edges. Just make them as it isn't symmetric since it is so small, right? Only 13. So just input X and Y. Then store the adjacency list or adjacency matrix. And also the LCA. Okay. Then should we make them zero base? Yes, maybe zero base is easier since we want to play with bit mask. So it is in between x and y. X and y is adjacent. CA between x and y is z. Wait, so we need to make them become -1 initially. One means unknown, so not given in the input. So then don't care about that. And if the LCA is not equal to -1, and also not equal to z as well, it means a contradiction, right? Just like this. If there is a contradiction, just see out 0. No need to do anything else. Other than that, just try to do dynamic programming, right? The root is always 1. Okay. So I think the dynamic programming is like this. dp mask and root is equal to the number of ways to make a tree with a specific mask with a specific root. So the output is dp p minus 1 0, because now it is 0 indexed. All right. Then how to find the transition? So I think we should check for our mask. And for our mask, we also need to check for our roots. But here we want to find dpij. Okay. And what is the base case? Base case is when it is the only node, right? This is the only nodes. What else? We want to try to split some childs, right? So how to do that? So we will try to split them, become some values, become some masks. And wait, how to do that? And we have to make sure this as well. M should be, sorry, for each pair that adjacent to this should be either to the child or to the parent, right? So if there is a node that adjacent to this, a node that exists here, so it means we should connect with this. This node should be become a direct child. Okay? They should be a direct child. And then the other node that outside this at most one, cannot more than one, because it is only connect with the parent. All right. And what else? We should make sure as well that all pair that the LCA is equal to M should be in different group as well. Because if they are in the same group, so the LCA is not equal to this node. And also all of that node should be under the subtree of M, cannot outside of this. All right, there are so many things we have to consider. So at first we want to check. Wait. Um, I think it is easier if we make it root and then mask. Yes, I think like that. Okay, let's change this. But wait, I don't think so, because from this we need the child is maybe with higher index, right? Not always the lower index. So how to do this? Okay. Maybe let's do this. We want to try to iterate for its submask of I. Yes, this is should be a submask of I, right? So we can start from I, no problem. Always greater than 0. Then k equal to k minus 1 and I. And there are so many restrictions here. At first, k should not contain j. If this is containing j, so just continue. We want to find this one, right? We want to find a subtree. We want to try to check for a subtree. Okay. And also the rest of the subtree. And then what else? Is there any double count there? Okay, I think this problem little bit costing some time and not really about some of our superset. So I think you can continue for your additional exercise. But to save our time, I think it is better to move to the next problem for now. Okay. So let's continue for problem T. For problem T, given an array of integer and for each number, we want to find another number inside the array such that it is compatible. What compatible means? Compatible means the n of them is 0. For example, 90. 90 is compatible with 36. All right. So just output 36 here. And 36 is compatible with 90 because when we do n operation here, the answer is 0. The result is 0. All right. How about this? 3 is compatible with what? You know, there is no compatible value with 3 here. because when we add to n operation between 3 and 6, it is equal to 2, not 0. So because it is doesn't exist, so just print -1. How about this? 10, there is no compatible value as well, so just print -1. How about 6? 6 and with 8 is equal to 0, right? So just print 8. How about 9? 9 and with 2 or 6 is also okay. I think 9 and 6 is also 0. So just print any of them. 8 is also either 6 or 2. You can print any of them. For 2, you can print either 8 or 9. Just print any of them. Is it correct? Any, right? Any suitable elements. Okay. Yes. Any idea to do this? When we want to find a compatible value from a specific value, for example, a value with this mask, it means we want to find a value that is a submask of this, a submask of the inverse, right? Just inverse this and then find a submask. Is it clear? Okay. See, do you agree with this? Okay. Then we just need to find any value that is submask of this, right? Okay. How to do that? Just use dynamic programming. Just use a dynamic programming. What kind of dynamic programming? After we input all elements, we will make a dynamic programming. And since the value is up to this, I think this value is less than 2 to the power of 22, right? This is 2 to the power of 20, and this is 2 to the power of 2. So just create like this. Maybe this is not my maximum n, or this just makes a, this is log. Maximum n is 1e6. All right. 0 never exists, right? Okay. It will make us easier. So just make dpai equal to ai. Of course, is correct, right? dpai is equal to ai. AI always a submask of AI itself. What else? Then we will run the DP. Just do this. Just iterate for all on bits. If I say like this. If the bit is on, then just do this. The bit is on, and also TPI XOR 1 2 to the power of j is not 0. If like that, so TPI is equal to this. All right. And then just output this. Just find max a minus 1 XOR this. Okay, just see out this, right? If there is no, just make it minus 1. If this value is 0, just make it minus 1. Or just make minus 1 here, right? If the TP is not 0, sorry, is into the p is 0, so just make it become minus 1. If not 0, just continue. Okay. Other than that, just minus 1. But try to find TP that is not minus 1. If we got a value that minus 1, just add. Can directly break it if we already got a value. Okay, so just see out in this way. All right, this problem is quite simple. Okay, yes, I think it is correct. All right, the same output. Okay, is there any question about this problem? So let's continue. I think we can submit this next time. And then let's continue to problem E. Your senior already solved this as well. So given n three word, all right. So you know a word consisting of 3 characters. Three. Okay. Or here 3 word. 3 word is sequence of exactly 3 lowercase letter, and the letter is only A to X. There is no Y, no Z. All right. And some of the letter are vowels. Okay. And then we don't know whether which is vowel, which is consonant, and each each word shall be contain at least one vowel. All right. Okay. So now we don't know the vowels, and we want to find some possible set of vowels. Okay. And then given a set of letters or set of vowels, and we have to check how many how many words that is contain at least one vowel, right? Okay, and we should try to find for all possible set, right? For all possible set of vowels. Of course, there are 2 to the power of 24 sets, including empty sets, right? Empty set means there is no vowel. That's why the number of correct words will equal to 0 as well. Okay, and that will not changing the answer, right? Since we want to find the XOR for the result. All right. For example, like this. ABC, AAA, ADA, BCDDEF. All right. We want to find for its sets, right? For example, sets contain of A. Then it means it is correct. This is correct. This is correct as well. But this is not. This is not. Okay, so the number of correct words is 3. Okay. And when the set is only containing D, for example, D here, only 2. If A and B, then 4. All right. We want to try all of the sets and then find the XOR of all of them. So is it understood? Okay. So so if the number of letters only 24, it means the maximum of this is around n plus 2 combination of 3, right? Okay. Yes, that's why n is around this value. And then what shall we do? If you want to find all of the result for each set, we are just like want to create an array with size 2 to the power of 24. And then when we are given sorry, a word contain of 3 letters, so we will try to what we will add to all values or all mask that consists of at least one of them, right? But if we do them one by one, of course it is so slow, right? But we can do this. You know, for a super mask of A will be increased by 1, right? And also our supermass of P will increase by 1 as well. And also for C increase by 1. So just increase this, increase this, increase this, and then just find sum over subset. Is it correct? How do you think? Maybe let me show you the implementation. So we will find the answer or the TP. We can use TP as well. We will input the string consists of 3 letters. And now log is 24. It is quite big, right? Around 2 to the power of. Wait, so we only can do this with complexity of 2 to the power of 24. We cannot multiply with another 24. Okay, but the time limit is 4 milliseconds. Okay, if 4 seconds, I think it is okay. Because if we multiply this by 24, okay, if the operation is like, so I think it can pass the time limit. Because sum over subset is so fast. So don't worry. Because only for loop and then the operation is so simple. Only adding a value from another value. Okay. So it's just like we can change the character into an integer, right? Always lowercase, isn't it? Okay. Yes, 3 lowercase letters. So should we just do this? So it is just like when we do prefix sum. If you want to add for all this, just add this only and then just do prefix sum, right? And how about this? If we want to add or supermask, just add this and then just do sum over superset. Is 24 or just log. This is maximum A. Just start from 1, right? If J, if, we, if the bit is on, then dpj plus by dpj XOR 2 to the power of I. and then just XOR for all of them. The output. How do you think? This is correct or not? Can you predict that? I think it is still incorrect. Just try the sample. But fortunately the output is same. But I think this is still an incorrect part. Why? Because yes, there is a case where there are some same letter, right? A, for example. We should not increase this by 3, right? Okay. What else? Even all the letters is different, we should not just increase all superset of this, all superset of this, all superset of this, right? Because if we do this, then all superset of 80, it will be increased twice. You got it? The intersect between this will increase twice. It is just like double counting, right? So we should exclude that. We should exclude that. So just do this. So it is just like inclusion and exclusion. Is it understood? Okay. Then just do this as well. And then just do this as well. And then how about the intersection of all of them? Just add again. All right. So how about now? So is it also can handle the same values? For example, when all of the values are same, so it means it is just adding the same index, right? Added by 3, minus by 3, added by 1. It is just like added by 1 only, right? Okay, so it is correct. For different letters, it is correct as well. For same letters, it is correct. How about two same letters and one different letter? So we will increase A twice, A increase twice, B increase once, and then A reduce once, AB reduce twice, and then AP increase once. All right. So it means the result is A only increase once, B only increase once, AB decrease once. That's it. It is correct as well. All right. So this implementation already handle for all cases. Okay. Is there any question about this problem? In implementation, maybe same. Okay, yes. So for this, it is the real SOS. Okay. Yes, this is one of the real SOS TP. All right. He is not sum, only just take one of them. I think it is different. No need to use all of them. Just like maximum or minimum. Maximum and minimum over subset is different because we can just take them and intersecting is okay, right? But some of our superset cannot intersect, right? Just like this, if we want to find dp in this, we cannot just find the sum between this and sum between this, sum between this. We cannot do that. But in max, min, or just take one of them, we can combine them without inclusion and exclusion, without this trick. All right. Then let's continue. So in here, given function f, g, and h. So let me explain the problem. So given a set of n different elements from 0 to n minus 1, of course, the number of possible set is 2 to the power of n, right? Yes, the number of subset is 2 to the power of n. And then each subset can be encoded as a bit mask. Just do this. For example, the set contain of 0, 3, and 4. It means just make a binary number. So the bit in 0, in 3, and 4, 1, 2, 3, 4, yes, is on. These bits are on. So it is equal to 25 in decimal number. All right. Okay. What is next? So if we have a triple of subsets A, B, and C that cover a subset D. Okay. Wait. Yes, triple ABC covers a subset D. If D is okay, yes. this triple cover this if the union of them is a superset of this. Okay. All right. Yes. So just like combine them and then solve the cover T. Not one by one, but if they are together. And given three function f, g, h, r, f, g, h is given, but r is, we want to find function r. All right. How to find that? So the function is, the input of the function is a set represented by a value between 0 and 2 to the power of n. What else? G is also, H is also, and all of the result is given in the input, I mean. And then R is equal to the sum of this for all triples that cover X. Okay. Is it understood? So you want to do brute force, just try to iterate 2 to the power of n, and then 2 to the power of n, 2 to the power of n, and so on. Just try to iterate FGH, and then if the R value of all of them cover this, then just add the multiply of them. All right. And finally, we want to find the sum of all R. Only the sum, not one by one. And modulo by this value. Okay. So is it understood? And it's only 20 and the time limit is 2 seconds. So we can think about contribution value. Just think about the contribution value. No need to find one by one. So for its triples, it will contribute how many number of times? Of course, will contribute 2 to the power of the pop count of them, pop count of the union of all them. Is it correct? Okay. Why? Because for this triple, it can cover 2 to the power of pop count number of sets. So it will increase 2 to the power of p values of R. And since the aggregating operation is also plus, So just plus the final result by this, like that. All right, that's one of the observation. What else? So we can also find the value for each 2 to the power of I. We can find all of the value that, sorry, for each mask, we can find all of the sum of FGH that the result are the union is equal to this mask, exactly equal to this mask. If you can find that, so for each of the value, just multiply by 2 to the power of pop count like this. All right. But how to find this? We can use inclusion and exclusion. So at first, just find sum of all of them. So each of the item in the triple is a sub mask of this. Okay. So for example, like this, A and B and C is a sub mask of X, for example. But if this, it is not always the union of all of them is exactly equal to X, right? But always submask of X. Okay, so after you want to find this, after we find this, we need to find the next step using inclusion and exclusion. Okay. And if you want to find this, it is easy, right? Because they can be counted separately. When we find A, don't care about B and C. And when we want to find B, don't care about A and C. When we find C, don't care about A and B. So they are individual as long as A is subset of X, B is subset of Y, sorry, subset of X as well, C subset of X as well. So it is okay. So when we want to add all of them, it means just add this, add this, add this, and then multiply all of them. This is correct or not? So for example, given 3 array A, B, C, if we want to multiply all of triples, this just like sum of this array, multiply sum of this, multiply sum of this. This is just same, right? How do you think? This is same or not? If they are same, so it means this is easy, right? To find this by finding each of this. How to find each of these? Wait, why not same? How about this? When we keep writing like this, example, sum added by AI times BJ times K. Okay. I mean, this is J, this is K. What if we count using this way? Okay, they are same, right? Okay, so we can use that. Then how to find the sum for all values? That is the subset of X. So just use sum over subset, right? Just find the sum over subset from that array. If given array F, just find sum over subset. Sum over subset means is just the same definition with this. Exactly the same. Alright. So we will do sum over subset for each array F, G, and H, and then multiply all of them. After that, just do inclusion and exclusion. After doing inclusion and exclusion, then just add the sum by its mass times 2 to the power of pop count of mass. Alright, then we got the result. Okay, and how to do inclusion and exclusion here? So we know for its mass, it is okay. I think for this part you can, it is for your exercise because now it is already 9 o'clock. So we can continue to the next meeting, inshallah. So I think that's all for today. Thank you very much for the discussion and good luck to solve all of the problem that we have discussed it. Okay, let's close our meeting with praying kafaratul majlis. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wassalamualaikum warahmatullahi wabarakatuh.